So we are now in our last chapter our last lesson in chapter 5 with grade 8 math. This is now looking at circumference and area and working between how to move back and forth between circumference and area. So let's just do a quick review of what we have already. We have the relationship between radius and diameter and circumference and moving back and forth between those. So radius times 2 gives diameter, diameter times pi gives circumference. Working backwards, circumference divided by pi gives diameter, and diameter divided by 2 gives radius. Now we have to include area into this equation, and we already reviewed before that area is equal to pi times the radius squared. So we square the radius first, then we multiply by pi to get area. Working backwards, and we looked at this derivation in class, when you are undoing this problem, normally you would do exponents first and then multiplication. But in undoing, you have to remove the last operation first. So you divide by pi first. So if I have my area, I divide by pi first because that's the first one to be removed. And then I remove the square by performing the square root on the area divided by that pi. So we'll look at a couple of those examples but if we remember this, then this will help us for the entire chapter. So, question 1, the circumference of the circle below is 50.24 centimeters. What is the area of this triangle? Well, if we're always stuck, we write down what we know and what we don't know. So we'll put our four quantities or variables on the side. We know that the circumference is 50.24 centimeters. And I want to know the area of this triangle. Well, let's look at this triangle a little bit. If we don't remember, the formula for the area of a triangle is base times height, which gives a rectangle or parallelogram, divided by 2, because it's half of that. So this would be the base, and this would be the height, because this is a 90-degree angle. So this triangle basically is turned sideways a little bit. And how is that related to the circle? Well, the base and the height are the same as the radius. So the base and the height are the same thing as radius times radius divided by 2. So I need to find the radius from this circumference. So working on this one, diameter is equal to circumference divided by pi, which is the same as 50.24 centimeters divided by 3.14. My diameter is, let me just pull this up, 50.24 divided by 3.14. My diameter is 16 centimeters. Just a little hint, normally when you get these nice round numbers, then you're probably on the right track. Radius is equal to diameter divided by 2. This is 16 centimeters divided by 2, and so my radius is 8 centimeters. So the radius is the same thing. Radius, let me just fill in what we don't know. And the question asks nothing about the area of the circle, so I don't need to find that. But I am concerned about the area of the triangle. So I just need to make a note here that the radius is equal to the base is equal to the height of the triangle. So that means area of a triangle is equal to base times height divided by 2. Well, the base and the height are both the radius, so that 8 centimeters times 8 centimeters, divide all of that divided by 2. 8 times 8 squared divided by 2 is 32 centimeters squared, is the area of the triangle. Let's look at the second example here. On a separate sheet, draw a circle that has an area of 176.6 centimeters squared. Well, again, on the side, I write down my four variables, and the one that I know is 176.6 centimeters squared. Now, the only thing we can find from the area is the radius if we use the equation area of a circle equals pi r squared. If we invert this, radius is equal to area of a circle divided by pi, and then all of it square rooted. Careful when we type this in the calculator. It would be helpful to type them in as 2 separate calculations, but if you want to combine it in one, it is important to put the brackets so that the calculator knows to do that operation first. So the radius is equal to the square root of 176.6 centimeters squared divided by 3.14. So this is the square root of and I get 56.242. Is that correct? Always check again. And then I find the square root of that. I get 7.4994, which will just round, so it's approximately 7.5. Then what I could do with that is this becomes the radius then for my circle. So then using the mark or using a compass. So if this is my compass right here, this distance will be 7.5 centimeters, or on the mark it would be 75 millimeters. So if we continue on, the area of one of these circles is 78.5 centimeters squared. What are the dimensions of this rectangle? Again, C, D, R, A. Oops, small r. The area of one of the circles is 78.5 centimeters. Well, let's think about this. How is the rectangle related to the circles? Well, this full length here is 2 full diameters. So once I have the diameter or even the radius, I'll be able to find that. And the height of this rectangle is 1 full diameter of this circle. So once I find the circumference and the diameter, the radius and the diameter, I can find the dimensions of this rectangle. So the radius of this circle is equal to the area divided by pi, and then I square root it. So that's 78.5 centimeters squared divided by 3.14, and then I square root that answer. Always be careful to make sure you square root after you do the division. So 78.5 divided by 3.14, I press enter, then I press square root after that, and I get the answer radius is equal to 5 centimeters. So radius is equal to 5 centimeters. Diameter is equal to 2 times the radius. So 2 times 5 centimeters is equal to 10 centimeters. So my diameter is 10 centimeters. So given the dimensions of this rectangle, dimensions of the length are 2 diameters long. So that is 2 times 10 centimeters equals 20 centimeters. The height of this rectangle is 1 diameter, and that is 10 centimeters. So the dimensions of this rectangle are 20 centimeters by 10 centimeters. The last question is a little tricky. What is the surface area of the following can? The top, the bottom, and the side. Draw a net of this can. Well, I won't be solving this one in class. However, what I can suggest you to do is just to break it apart. I have a circle at the top. Then I have this kind of side part, which if I break apart actually looks like a giant rectangle. This should be a better rectangle. And then the bottom part of the can is also a circle as well. So given that, I can take the information from the can. So this is the diameter is 7, and this kind of height is, or this height is 10 centimeters. So I'll just put that in my net right here. So I have my diameter is 7 centimeters. Now we can find the area of these two circles by using the radius. So radius is equal to diameter divided by 2 is equal to 7 centimeters divided by 2 is 3.5 centimeters. So the area of one of the circles is equal to pi r squared. It's equal to 3.14 times 3.5 centimeters all squared. So I do 3.5 times 3.5, and I get 12.25. 12.25 centimeters squared. And so the area of this side panel is equal to length times width. The width we know is 10 centimeters. It's this length that we're tricky, but as you can see, it's the distance all the way around the can. Well, that's the circumference. So the length of this is actually the circumference times the width. Circumference we can find on the side. Circumference is equal to 2 times pi times r, or pi times d. Diameter we know is 7, so it's 3.14 times 7 centimeters. So 3.14 times 7 centimeters, I get 21.98 centimeters as a circumference. So that means the area of the rectangle equals 21.98 centimeters times its width, which is 10 centimeters, and that gives me 219.8 centimeters squared. The total area then of both the top circle, the bottom circle, and the side equals 12.25 centimeters squared plus 12.25 centimeters squared plus 219.8 centimeters squared. I'm running out of room here. So 12.25 plus 12.2, 12.25 plus 12.25 plus 219.8. I get a total surface area of 244.3 centimeters squared. This is a bonus type question, but it does exercise all of the area, circumference types of problems that we're going to be looking at. So